Hello, everyone. Are you in the right classroom or not? I remember all of you, but I'm just asking. Maybe you wouldn't like to be here. Okay. Let's get to the point. Do you want to get the point?
No.
No? Okay, next time. Or maybe you can go out. That's another option. Okay. We'll talk about something different today. I'll start with an example, and then we'll see what this whole thing is. First of all, sequences. Do we know what that is? Probably yes. Okay. If you have a sequence that looks like this, do you know what to do with this thing? Do you know if it can converge or not? What's the limit? Well, this is something strange. This is called a recurrent sequence. Because if you want to find out what's the next element of the sequence, you need the previous value, in this case. So, if you want to know what's the next value, you need something, an initial value, somewhere to start. That also plays a big role in this thing. If I give you this to be the initial value, what's the next value? Square root of 2 by 2, which is 2. Right? Next one. This one is 2, and there you have 2. So it's again the same thing. Right? If you go on and on this process, you'll see that these patterns keep going on. So you can say that this sequence is this. Right? That's what you get. On the other hand, if you change the initial value, if you say a1 is equal to 1, then a2 is square root of 2 times 1, which is square root of 2. And a3 is square root of 2 times square root of 2, and things are getting more complicated on this part. So what can you do? You see, first of all, you see that if you have a different initial value, you have a completely different thing. So you have to come up with some process so you can find out what's going on. Okay? We'll see that with a more complicated example. Does anybody recognize this? Just you. Yeah. This is the Fibonacci sequence. Some people define the initial values as this, or 1 and 1. That's not a big difference. Okay, what can we do about this? Now, it's more complicated than this. It's not something that you can say, okay, I have this sequence of 2's, so that's what I get for this. What do I do about this? Just bring everything to the left side. Okay? Let's say we'll just stay here with this formula. What can you say about this? There is something called characteristic polynomial. What is that? First of all, I'll just use a more abstract form of this. Let's say this is a2 Okay? I just put here some constants, these values. The characteristic polynomial looks like this. Okay? Now we can do something with this. You have the same constants, and you just change these with this part. You have the unknown to the power that you had over there. Okay, can I erase over here? What you do with that, you want to find the roots of this thing. So, okay, I'll change back the constants. This is equal to 0. Okay, I can divide by this. This is not 0. If it's 0, then something is going wrong, so I can divide. That's okay to do. It's okay to do it. So I get simple stuff. No? Well, you know what to do with this thing. I'm not saying that you know the rest of the stuff. You know what to do with this one. This will give you something that looks these are the roots of this thing. So, what am I going to do with that? What the textbook says. I'm making some jumps over here because it's difficult there. Okay. What you get is something that looks like this. And if you use the initial values, then you know these two constants, and the whole thing is solved. But we don't have any more time, so I'll continue from this point on the next time.